So we had to restart due to certain error. So now the process ID for malware will be 436. So we'll be running DLL list on process 436. You can see that in the malware actually only imports NTDLL WAL64 and just this field. However, we know from our previous analysis actually import kernel 32 WS2 underscore 32. So that means the malware actually hides the DLL that it do. The module is called LDR modules, which will show us the hidden DLLs. So here you can see that the malware actually imports a lot more other DLLs, such as user 32, up to those that covered in our analysis. So we know that the malware actually hides. So yeah, you can see the malware created syslog.exe as predicted from our analysis, and actually created a few other DLL for its own usage. So these are basically the host operations performed in the system. So now we'll be moving on to network analysis. So in our network analysis, we start the update DNS to check if the malware makes any DNS requests, and as you can see, there is no request of any sort. So you can assume that the malware actually does not make any DNS requests. So now we'll be moving on to process monitor. So as you can see, the malware actually connects to a certain IP address which is 10.24.9.100. So you prove that the malware actually has network connectivity and will attempt to connect to a host that is presumably malicious. So now we'll be going to volatility. So we'll be using something called conscan, which will basically scan for any remote connections made to our VM. So as you can see here, the malware has actually attempted connection to the IP address we have discovered from earlier analysis, 10.24.9.100 to the port 7358. And the process ID is 436, which from previous analysis we actually know that is malware.exe. So now we'll choose the interface, which is our VM's interface, and start the monitoring. So again, all these are default VMware activity, which will happen normally as the VM actually goes on. So from our analysis, we realized that the malware will actually attempt to connect to, and it appears here, will actually attempt to connect to this IP address periodically, as you can see. So we can confirm that actually using this TCP packet, the malware is attempting to connect to a malicious host. So now last but not least, we'll be moving on to using Immunity Debugger to analyze our malware. So the first DL to be imported is NTDL, which has not much use to us, so we'll skip it, and kernel 32. So now we are at the module malware. We can first search for all reference text string. So you can see actually this is the pack malware, so you can't get anything useful. So now we'll switch to the unpacked malware. So now I have switched to the unpacked malware already. As you can see, there's actually a lot more content. If you search for reference text string, you can see here that several strings are very important, such as this one, which is the registry key, the name of the file that's going to be created, user day2 message program. This tree will indicate that the program itself is actually trying to monitor our active window by taking over our screen, like looking at what we are doing. So we'll now go into the code to see where the code is. So first we'll start by going to the directory for the registry, and you can see here get window directory syslog is actually looking to add this file, looking to copy the file to the registry, and by creating a registry key here to execute the malware automatically upon start. As you can see, the set value actually sets the value name Microsoft syslog, which is the value of the file. So this part you can see is try alpha numeric, and using string compare and rec delete value, this part and string copy, we infer that this malware might actually be a keylogger because they are checking and comparing string, possibly registry value. So this could be a keylogger. So now come to WSA socket A, which is used to create a Windows socket. This can be assumed that the malware actually creates a Windows socket to initial connection. As you can see from our previous analysis, the malware do initial connection to IP address. And here it says timeout 30,000 milliseconds sleep. So it can be assumed that after execution, the malware will sleep for 30 seconds. Sorry, I mean sleep after 30-second timeout, and after timeout it will sleep indefinitely, which means the malware could actually execute indefinitely in the background. So now we look for the next string, which search for. So here you can see that it actually imports user data.dll load library, and it has a field here which cannot see the string unless we assemble the code. So there's 3 Arduino here, so we shall assemble them to get the value. So you can see once I assemble, the ASCII value for it is message box A, and for the rest too, get active window, get last active pop-up, and yeah. So for this tree, we can deduce that the malware is actually a keylogger by keeping track of our message and the active window and the last active pop-up. However, during our malware execution, no pop-up was encountered. So this concludes our my dynamic analysis. Thank you.